Welcome to MOVI-C Control Cabinet Products Basic to Intermediate Training. This is session 19 and lab 10. It's also the final session of this class. By the way, when I come to the end of the lab, be sure to continue through to the end because I have a few final remarks to give about the class itself and also to remind you where you can go to get help if you need it. So let's dive in and do our final lab. We're going to be doing a lab with the position control MOVIKIT. We've already done one MOVIKIT lab with velocity control a number of sessions back. This is the second MOVIKIT we're going to be looking at. It's an extremely useful one and one that many people use. So we're going to look at how it works and explore it in a little more detail. Let's get started. First of all, just a reminder about motors. This lab works with either motor type, either the asynchronous motor or the synchronous servo motor. You can use whichever one you like. If you configured it correctly for the lab we just did, that's perfectly fine. Just leave it in that mode and you're good. I'm going to be using a servo motor for this lab, so that's what you'll be seeing. Okay, let's do some pre-lab instructions and then we can jump in and do the lab itself. First of all, very important point, you must have a MOVI drive technology with application level 1 or 2 to run MOVIKIT positioning. Remember, you could run MOVIKIT velocity control on level 0, but MOVIKIT positioning does require either 1 or 2. I have a level 1 MOVI drive technology, so I'm fine. Also, just a reminder, MOVIKIT positioning is available as a controller level MOVIKIT as well, and it works similarly to this. We won't be exploring it, but what you learn here does apply to it. Another reminder, since we talked about this several sessions ago, the positioning application uses 8PD control. And you remember that in 8PD control, the PLC and the controller or the VFD exchange 8 process data words in each direction. So let's just review these quickly. The process output words, POs, that go from the PLC to the VFD include these. PO1 is the control word. Individual bits are significant. They turn things on and off. PO2 sends the speed at which positioning occurs. PO3 and 4 handle acceleration and deceleration by providing the ramp values. PO5 allows you to control the digital outputs on the MOVI drive. PO6 is the mode. This selects which mode you'll be in. We'll go into that in more detail later. And then PO7 and PO8 provide the position, or in some situations, the offset during referencing. Why are there two POs for position? Well, the answer is these are 16-bit words, and you can't represent really huge numbers in just 16 bits. So what we do is we combine 7 and 8 together, which gives us effectively 32 bits. 32 bits gives us a numeric range of over 4 billion, and so that is very appropriate for positioning. 4 billion millimeters or inches is a pretty big distance, so that allows us to position virtually anywhere. Now, the VFD, or the controller in a controller level MOVIKIT, will be sending back 8 process input words. PI1 and PI3 provide status information about what's going on. PI2 provides the current speed. PI4 is user configurable. PI5 is the status of the VFD's digital inputs. PI6 reports the mode it's in. And again, 7 and 8 together provide the current position, which will change as the drive is positioning. So you can use that to get an idea where you are. So that's a review of 8PD control. Now let's talk about some of the things that you have to set up in order to use the MOVIKIT. Of course, the first thing you have to do is add the MOVIKIT to the axis. So you go to the bottom of the axis circle and click on it, and that will bring up a list of available MOVIKITs. You can also right-click on it and pick the Add from Catalog option from the menu. That will do exactly the same thing. You'll know you're successful when the symbol for the positioning drive appears at the bottom of the axis circle as it shows here. I don't think I've mentioned this before, but I'll point out that drive level MOVIKITs have a little D in the corner of the symbol. So those clue you into the fact that these are drive level and can be directly associated with the axis rather than controller level, which run on a separate controller. Once you've added the MOVIKIT, you will have some extra menus. They appear in the menu group MOVIKIT Positioning Drive, and you can go to these to set the different things required to get the MOVIKIT up and running. So let's take a look at those. The first thing that is absolutely essential when you're working with MOVIKIT positioning is setting up referencing. We've just spent an entire session learning about referencing. It is obviously very important. You'll need to be able to reference your drive before you can do any positioning. So this is the way you set that up. You, of course, click on the bottom of the axis circle to go to the appropriate menu group. Then you pick Drive Functions and the submenu FCB12. That's the function control block associated with reference travel. And you'll pick the reference mode there at the top from the pull-down list. Right now it's set to limit switch positive, but you can set it to whatever is appropriate. You can also enable or disable the encoder's zero pulse. You can set the two speeds used for referencing, the higher search speed and the slower retraction speed. And if you wish, you can set an offset. You can set an offset by parameter. Notice it goes to 2 decimal places, so you can go down to 1/100th of a revolution for the offset. If you don't wish to use the offset, just set it to 0, which is what it defaults to. Of course, you can also set your acceleration and deceleration ramps here. So that will configure your reference travel. Let me mention just as an aside that you can do an alternative way of setting up an offset. Instead of hard coding it as a parameter, it is possible to send it over the field bus, which would allow you to have potentially several different offsets if you do that. That is more flexible. If you wish to use field bus offset, what you will do is send it in the position POs, PO7 and PO8. I'm just showing you this in the diagnostic screen. You can send the offset there. Instead of a position, you do this when you're in referencing mode, and that will apply instead. Of course, if you're not using an offset, which is most applications, then you would just send a 0. Something new I want to talk about with positioning, we haven't talked about this before, and that is lag error. What is that? Well, it's something you set up in FCB09, which is the positioning FCB. Lag error is the difference between the expected and the actual positions. In other words, what the VFD thinks the position should be and what the encoder is reporting its actual position is. If lag error is too big, it means something is going wrong. It may mean that there's some kind of opposition to the drive, like some kind of friction problem or a jam, or simply the drive isn't positioning correctly. So it's something we don't want to allow to continue. Normally what happens when lag error becomes excessive is the drive shuts down and then somebody has to investigate what's going on. Now this is where you set how much lag error you want. You set the lag error window. It defaults to 1 revolution. If there is more than 1 revolution difference between the expected and actual positions, it will go into the fault condition. And what's important to notice here is you can also configure the response. Right now, it's set to output stage inhibit, so that would simply shut the VFD down. But you could set other responses, and you could even say to ignore it if you wished, although that is not typical. For this lab, you can just leave lag error set to its default. That's fine. You won't get any lag error in the lab in all likelihood. But in a real application, you would need to set it to something appropriate to the actual machinery that you're driving. All right, so that's lag error. Now let's look at the modes that are available with this MOVIKIT. Again, I'm showing you in the diagnostic screen since you can use this to test your MOVIKIT. This MOVIKIT has a lot of modes. You can see there are many different modes. It includes the ability to jog in 2 different ways. There's actually a velocity control mode, so you could potentially use this MOVIKIT to do velocity control as well. It has referencing using the hard-coded parameter and referencing with the offset through the field bus. It has 2 linear positioning modes, and it has what is called modulo positioning, which is circular positioning, where you move to a specific angular position instead of linear position. This might be used with a turntable, for example. We won't be going into modulo positioning here. It's fairly complex to set up, but we may release an individual standalone tutorial on that in the future, so keep watching our YouTube channel. You set the mode that you're going to operate in by sending its number through P06. And I'm just going to point out the numbers shown here are decimal, not hexadecimal values, so you would probably have to convert these to hexadecimal if you're programming this through a PLC, since that's usually how you send codes, and you'd send them in hexadecimal instead. There are two positioning modes available through this MOVIKit. I want to review them very briefly just so you understand how they work and how they differ. The first is called absolute positioning, and it is always referenced to the machine zero position. Positions are absolute distances, either positive or negative, relative to the machine zero. So in this case, you can see a travel application. We have a little cart here, and it's sitting at the machine zero. Maybe it's just been referenced, and it can travel along a linear track. You notice the distances are marked out here. These are in revolutions from the machine zero. So when you issue a positioning command, you're going to one of these positions absolutely. Let me give you an example. Let's say I tell the VFD, go to 1000. That's positive 1000. It's 1000 revolutions relative to zero. What will happen is the cart will move here. Now, what happens if I say go 1000 again? What will happen? And the answer is absolutely nothing. The VFD will say, that was stupid. I'm already sitting there. So it's not going to move. If I say go to 1500, of course it will. It'll go to the position between 1000 and 2000. And if I say go to minus 2000, then it's going to jump way over here to this absolute position. So that is one type of positioning. It's a mode available in this MOVIKit. The second positioning mode is relative positioning, and this is a second mode in the MOVIKit. How does it work? Relative positioning operations are always based on wherever you currently are. They really don't care about the machine zero. They are simply offsets from your current location. For example, if I said go to 1000 and I'm starting at 0, it would go to 1000. Now this looks just like absolute positioning up to this point, but actually it isn't, because if I say go to 1000 again, something different happens. It goes to 2000. It takes my current position, adds a positive 1000 to it, and moves that distance. That is definitely different. And then if I said something like go minus 2500, it would take my current position, which is 2000. It would add minus 2500 to it, which is minus 500. And it would wind up here. You can see relative positioning is different. We give you both of them simply because it gives you a lot of flexibility, and you can use either one, whatever your application demands. Those are the two linear positioning modes that are available. All right, so now it's time to pause the video and do the lab. All right, well, I hope you found that useful and instructive. We're now going to do the lab walkthrough, and you can see how I did it. We'll be exploring a number of different things, including multiple referencing modes, and when it's over, we'll do our class wrap-up, so be sure to stick around to the end. Okay, well, we are now ready to work with a positioning MOVIKit. As you can see, I've got my project open. This is where we left off in our last project. Remember, we had switched to CFC mode, so everything should still be there and ready to go. In fact, it's a good idea that you're in CFC mode because positioning works especially well in that mode. The first thing we need to do is attach the positioning MOVIKit to the axis. Remember, with MOVIDrive technology, we're using drive-level MOVIKits, which associate themselves directly into the VFD. They don't run on the controller like the controller-level ones do. And of course, you've seen this before with velocity control. We click Add Software Module, and we pick Positioning Drive. Now, I have a MOVIDrive technology that's application level 1, so it supports this, but if yours happens to be level 0, it won't be able to run this, and you'll either have to go and call our customer service department and upgrade your MOVIDrive technology, or you'll have to switch to a different one. So I'm going to pick Positioning Drive, and I'm going to add that to the axis. And yes, I'm going to let it change parameters, because it definitely needs to. And there we go. We can see that it has successfully associated itself with the access because its symbol appeared. Now I notice we've got a fault. We got a fault immediately, so clearly something was changed that tripped this fault. We need to figure out what it is. I'll just click the little lightning bolt and I say, uh-oh, I got a limit switch hit. So what probably happened is MOVIKIT positioning drive activated some limit switches, and all the switches on my control box are off. And as you know, limit switches are active low. So of course we got a limit switch trip. We better take care of that. I better turn those switches on and then clear this fault. As it happens, I know that it assigned DI02 and DI03 to the limit switches, so I need to turn those on right now, and then I can clear my fault. All right, so that's taken care of. We're back to 01, which is just control or inhibit, so we can continue setting up our MOVIKIT. The next thing we need to do is configure some of the MOVIKIT options. So I'm going to click the bottom part of the axis circle, which will take me most directly to the appropriate menu group. And I'm going to move down here. I'm going to go to Basic Settings, which is where it defaults to. And first of all, I have to tell it where to get its commands from, and that is the Field Bus card. So I'm going to change this from Standard Bus System to Field Bus. That's okay. Now, sometimes this can trigger a fault, and there it did. It just triggered one because we connected it to the Field Bus card, so I need to clear that. So let me just click this. It just says some things changed. Okay, I'm not surprised. Let's get rid of that. Again, we're back to 01. Everything's fine. Now, we need to set up a way of referencing the drive because when you're doing positioning, you've got to reference. So I'm going to go to the Drive Functions menu here, and I'm going to pick FCB12 Reference Travel, and that's going to let me pick my reference mode. Now I'm going to go with the cheating reference mode, the one where it doesn't have to do any traveling, where it just says, hey, you're referenced, and guess what? Actually, that's the one it defaults to, so I don't have to change anything. But of course, if it was something else, I could come in here, look at the different choices, and pick referencing without reference travel. My reference speeds are 250 RPM. That's fine. There's no reason to change that. And I'm going to keep the acceleration ramps left just the way they are. Those are fine as well. We do need to take a look at our IOs here and make sure things are set up correctly. I'm going to go to Inputs and Outputs. I'm going to make sure that the MOVIKIT default assignment is freely configurable. And what I'm going to do is I'm going to clear some of the settings that the MOVIKIT inserted by default. Notice it picked a reference cam and hardware limit switches, touch probe, input, and a fault reset. I don't want any of that at this stage. Later on, we'll play with some of those things. But meanwhile, I'm just going to change all these to no function so they don't interfere with what I'm doing here. I'm also going to change the digital outputs to control by field bus. So there we go. Now, if you remember from the MOVIKIT velocity control, one of the process input words, PI4, is user configurable. You can assign that to report one of several parameters. I'm going to set that here just kind of for fun. So I'm going to go under MOVIKIT positioning drive, and I'm going to pick the field bus interface menu. And I'm going to change PI4 from torque and percentage of nominal motor torque to relative current and percentage of nominal current. So that's just what I choose to have it report. You could pick something else. It really doesn't affect the lab. And then finally, the last thing I need to do is set my field bus IP information. So I go back to communications. I pick field bus. You've seen me do this before. Notice it defaults to DHCP, which means it gets an automatic IP address from a domain host control protocol server. I'm not going to use that. I'm going to change it to saved IP, and I'm going to put in the standard SCW IP address. Remember, you tab between every field except the very last, and then you must hit enter, otherwise you can fault the drive. So I will key in 192.168.10.4, which is the default SCW address, 255, 255, 255.0, which is the appropriate subnet mask, and 192.168.10.0 1 for the default gateway. I am very careful not to hit tab. I hit enter, and then I click apply address settings, and that has configured my Fieldbus card. Notice I didn't get any kind of fault, so everything's good. So now we're ready to test by going into MOVIKIT Diagnostics, and this will allow us to take over the VFD almost like we were a PLC. So that is now our next step. The first thing we have to do in diagnostics mode is take control of the VFD directly. So we're going to click the activate button. This takes us out of monitor mode and puts us into control mode. So now we're simulating a PLC. I'm going to turn the hardware controller inhibit switch to the right position first, just so it doesn't interfere with us later. And now we're ready to run our application. The first thing we're going to play with is jogging. I'd like to point out what the process output words do to control the MOVIKIT. P01 is the control word. It has individual bits you turn on and off to change things, and as you remember, they're displayed right here as little toggle switches, and you get the hexadecimal value here. P02 is the speed. P03 and 4 are the acceleration and deceleration ramps. P05 lets you manipulate the digital outputs. P06 is the mode. This is actually a pull-down box here, and you can see it has the numbers that you would have to put in there if you were sending this from a PLC. These are decimal numbers, by the way, not hexadecimal. So I'm actually going to pick jog mode right here, speed control jog mode. That's number 101. I'm going to put that in there. And then we have two process output words, 7 and 8, for a position. And notice they're telling you, don't forget you've got that pseudo fraction there where you can go down to hundredths of a revolution. All right, so those are the process output words. Of course, P01 is broken out here. Process input words provide status. Those are displayed here. And we also have PI1 with the individual bits broken out and defined, so we can get status of our drive. All right, to jog, all we need to do is put it in jog mode, which we've done by setting P06 to 101. We need to give it a speed. Let's key in a set point speed. I'll pick 250 RPM. I'm going to pick a ramp of 500 RPM per second for both acceleration and deceleration. And of course, nothing's happening yet, and that's because we haven't activated the control word. So we need to go ahead and do that. We need to flip a few bits, and we should be jogging in just a second. First thing to do is remove the software controller inhibit. That's bit 13, which is turned on. I'm going to take that away. I have two enables that I have to turn on. And I just heard a click as the brake released, so obviously I'm getting there. Now you notice bits 4 and 5 are called jog positive and jog negative. If we click bit 4, we should rotate positively. And sure enough, our drive is fired up, and it is jogging in the positive direction clockwise. Let me stop it, and I'll go the other way. You can see the little speedometer changes, and also up here, PI2 gives us the actual speed, and it's 250 RPM. So that is jogging. Very simple and straightforward. Now, if we're going to do positioning, we need to reference the drive. Now, we're in the easy referencing mode, so all we really have to do is change to referencing mode and trigger it. I go to P06, I pop the list down, and I look for referencing, and I'm going to pick reference mode 301. That is reference travel with the offset sent by the field bus. You can also use the built-in parameter, but we'll go ahead and use this one here. So I will pick reference travel. And all I have to do now is trigger it. And the way we trigger referencing is we change bit 7 start stop with field bus ramp, just on and off. The drive clicked, and you notice this bit in PI1, bit 5, has just turned on, active drive referenced. So that means we're all set. We're now effectively at the 0 position. And if you go up here to PI 7 and 8, which tells you the actual position where you are at the moment, notice we're right at 0. That's because we haven't set an offset value, so our offset is just 0 at the moment. Okay, so we're referenced. We're now ready to position. Let's change to absolute positioning mode. That is mode 400. So now we're ready to go to a specific position. We do need to set a few things though. We need to set our travel speed. Let's use 1,000 RPM. And we'll use an acceleration ramp of 2,000 RPM per second. And we'll use a deceleration of 500, so we'll just leave what's in there alone. And now we're ready to position. We need to enter a position in the target position, and we can't forget that the last two digits are going to be the fraction of revolutions. If we're going to an integer value, we need to add 2 zeros on the end, otherwise we're not going to position far enough. Let's go ahead though and do something with a fraction. Let's go ahead and go to 50.25 revolutions. So I'll type in 50.25 and hit enter, and that should rotate 50 times and then a quarter of a turn. Now to make it actually go, of course, I have to trigger bit 7, start stop with field bus ramp, so here we go. And you can see my current position is changing. And there we go. We've arrived at 50.25 revolutions and we're done. Notice something else. We have another bit that lit up when we arrived in PI1. It's this bit here, 7, in position. And that tells us when we've arrived at a given location. Let's go to a new location. I have to turn my bit off here so I can change my position. Let's go to 100.1. So 100, 10, hit enter. Now watch that bit in position as I turn bit 7 on. And there we go. Okay, so that is just elementary positioning. If you sent these bits with a PLC and sent the values in the other POs, then it would do exactly what it's doing here in diagnostics. Let's go back to location 0 here. I'll type a 0 in. I'll turn my start stop with field bus ramp on. And the drive's heading back to the home position. And there we go. It's arrived and it's stopped. So that is absolute positioning, where it goes to a specific location reference to the home position. Now, I'd like to look at a second positioning mode. This is something called relative positioning, and I'm going to change my mode here from absolute to relative. That's 400, and I change it to 401. Relative positioning is different. It simply moves relative to where you currently are. So when I type in a position, it's going to take where I am and either add or subtract that value from my current position. A little different from absolute positioning. So let's give it a position. Let's say move 50 revolutions relative to where I am now. Of course, I'm at 0, so if I type in 50, and don't forget I have to add 2 more zeros here because that's the fraction. Okay, now I need to do something slightly different in PO1. I've got to turn on bit 6, apply relative position, and now I turn bit 7 on, and off it goes. Now, if I had done this in absolute positioning, you'd get the same exact effect, because in absolute positioning, you position relative to the home position, and I already happen to be there. But let me show you something different now. I'm going to turn start stop with field bus ramp off. I'm going to turn apply relative position off, and then I'm going to turn them both back on again. And notice it moves another 50 rotations now to 100. If I had done that in absolute mode, it wouldn't have moved. It would say you're already at 50, so there's no reason to move. So if I turn these off again and back on again, it'll move another 50. So you see we are definitely doing something different. Let me turn these off, and let me say go back minus 25. So I'll put in minus 25 and then add 2 more zeros. And I'll turn this on, and now it's going to go back 25, and our position is 125. So that is relative positioning. Pretty simple and straightforward. Let's turn these bits off. If I want to go back to 0, I can't put in 0. If I put in 0, actually nothing will happen, because 0 relative to where I am is just where I am. But if I want to go back to 0, and I'm currently at 125, if I put in minus 125.00 and hit enter, and turn these bits on, that should bring me back to my 0 location. And there we are. We're at 0. So we're going to shut these bits off now, and I'm going to remove the enables. And I'm going to turn the software controller inhibit back on, and also I'm going to flip my hardware controller inhibit. And finally, I'm going to release control back to monitor mode by clicking deactivate and say yes, because I need to make some changes to my MOVIKIT, and I can't do it while I'm in control. We're going to finish up this lab by playing with a few referencing modes. So far, we've kind of used the cheating referencing mode where you just say, wherever you are, be referenced. That's easy, that's fun, but it's not necessarily realistic. We need to play with some of the ones that actually move the drive and use referencing sensors like referencing cams and the limit switches. So we're going to make a few changes for that. Now you can see we're at the point where we're back at our axis circle. We're now going to make a few changes. So I'm going to just click the top of the axis circle to go back to the menus. I'm going to go to the MOVIKIT positioning drive menu group, and I'm going to pick drive functions. I'm going to pick FCB12 reference travel, and I'm going to make a few changes. I'm going to change to referencing cam negative end. This is our first referencing cam type. Remember, there are two groups of these, one where the cam is probably somewhere in the middle and one where the cam is sitting next to a limit switch. This is a case where the referencing cam is sitting somewhere in the middle, and our goal is to wind up on the left side or the counterclockwise end of it when we're finished. So I've changed that mode. I'm going to leave reference to zero pulse off so it doesn't rely on the zero pulse on the encoder. My encoder has one, but yours may or may not, so I'm going to leave that turned off. I'm also going to leave reference offset set to 0, but I am going to change the search speeds. Remember, we have two of them. We have a higher speed and a lower speed. I'm going to change the higher speed to 150 RPM and the lower speed to 25. I'm also going to change my ramps to something a little faster, 9,000 RPM per second, both acceleration and deceleration. Now, let me just quickly review what's going to happen when we reference in this way. The VFD is going to run the drive counterclockwise, and it's going to do it at the higher speed, 150 RPM, until it touches the reference cam. It will then slow to the retraction speed, 25 RPM, continuing to move counterclockwise until the cam releases, at which point it will then stop. So this is a fairly simple referencing mode, so we should just see the drive turn counterclockwise at 2 speeds when we do it. We do need to go to the I/O menu and assign our reference cam, so we need to do that first. We're going to make the reference cam DI01. And there it is, FCB12, reference cam. And we're going to use the limit switches later, so I'm going to assign them to DI02 and DI03, but I better switch those on my control box first so I don't get a fault. I don't have to turn the reference cam on. Remember, it is active high. So there we go. I've assigned my 2 limit switches, so we're now set to go. I'll go back to the MOVIKIT diagnostics menu and switch out of monitor mode back to PLC simulation mode. Now, in order to reference the drive, I have to change my mode in P06. Right now it's set to speed control. I'm going to set it to 301 reference travel offset via field bus. That means I can send my offset, if I wish to have one, through the field bus. I'm not tied to what's hard-coded into a parameter. If I wanted to use a parameter, I could have picked 300, which is reference travel offset by a parameter, but I'm going to keep this. If I wish to put an offset in, you'll put it in P07 and 8, which is usually used for the position, but during referencing can be used for the offset. We won't play with the offset yet. We'll just leave it set to 0 at the moment. So now we're ready to reference the drive. The first thing we have to do, of course, is get everything enabled in P01. I'm going to turn my hardware controller inhibit switch on first. Then I'm going to remove my software controller inhibit bit by turning bit 13 off. I'm going to turn bits 0 and 1 on to enable the drive. And I will trigger referencing with bit 7 start stop with field bus ramp. So what's going to happen is the drive will start referencing by turning counterclockwise at the higher speed until I tap the cam, I'll do that by flipping DI01 on. It'll slow down. I'll turn it off to simulate coming off the cam, and it should stop. So let's try that. Turn my bit on. And we are definitely running at 150. Now I'm going to tap the cam, and I'm going to come off it as well. And there we go. Referencing is finished. I'll turn bit 7 back off to end it. And if we go up here to PI 7 and 8, actual position, it's now showing it at 0, which means we've referenced successfully. Also notice that bit 5 and PI 1 is on, active drive referenced, and that confirms we have successfully referenced. Now let's go ahead and do this again, but this time we're going to do an offset to simulate a reference cam that is not at the machine 0 position. Let's say that it's 12 revolutions clockwise of machine 0. Now that's a pretty small distance. In real life it would probably be bigger, but we'll just put in 12 just kind of for fun and try referencing. What I'm going to do is just reference again. I'm going to put in the offset. Remember, I have 2 pseudo-decimals, so I need to put in 1200 for 12.00, not just 12. Otherwise, it would go only 0.12 revolutions instead. So I've put in my offset. I'm going to trigger referencing again by turning bit 7 on. See, my drive is running. Now let me tap my cam. And there I've come off the cam. I'll turn my bit off. And look at my actual position. Notice it says 12.00 revolutions. So I am now referenced. I'm at the sensor, but I'm not at machine 0. If I were, it would be 0, but I'm at 12. And that's exactly what we're supposed to see. We're supposed to see the offset rather than 0. So there we go. That worked just fine. And of course, remember that sign on the offset indicates the relationship. So we are plus 12 revolutions, in other words, clockwise, of the actual machine 0. If I changed to a travel mode and did go to 0, my drive would run counterclockwise 12 revolutions until it got to 0. In fact, let's just do that for fun here. I'm going to go into mode 400 absolute positioning. I'm going to change the position to 0. Okay, I put 0 in. I better set a speed here. Let's just say go at 1,000 RPM. We can leave the ramps alone. Now I'm going to trip start stop with field bus ramp, and you should see the drive spin 12 times counterclockwise. There it goes. And it's at 0. So it works just like it should. Pretty nice. All right, now let's play with a different referencing mode. Let's play with using the limit switches. So in order to make a change, of course, I've got to disable my drive, turn my software controller inhibit on, turn my hardware controller inhibit switch off, and then release control of the axis, go back to monitor mode. Then I go to drive functions, FCB12, and I'm going to change my mode to limit switch positive. That means it's going to go to the limit switch at the clockwise end, so it's going to travel clockwise towards it. It will tap it, then it will retract. It will approach it at the higher speed, retract off it at the slower speed. All right, pretty straightforward. Let's go back to MOVIKIT Diagnostics. Take control of the axis. I'm going to change my mode to reference travel offset via field bus. I'm going to just leave my offset at 0 here, and I'm going to trip referencing again. Of course, I've got to enable my drive first, so I need to turn my hardware controller inhibit on, remove my software controller inhibit, enable my drive, and I'm going to start referencing. So we should see the drive turning clockwise, which it is at the higher speed. I'm going to tap the limit switch by turning DI02 off. It's going to go backwards at the slower speed, and I'll turn DI02 back on to simulate coming off the limit switch. Here we go. And there we are, we're referenced, and PI 7 and 8 shows 0. Let me turn my bit 7 off. And notice it says active drive referenced right here. So we have fulfilled everything. So that is limit switch based referencing. And that is it. That is the end of the lab. And you've also reached the end of the course. So we're going to go and have a quick wrap up, and then you'll be done. Good work hanging through 10 labs. All right, well, as I've just said, that is the end of the class. Good job. You have gotten through 20 videos and hopefully learned a lot about the MOVI-C control cabinet products. Now, let me just remind you what I told you back in the very first session. What do you do if you have questions? Well, you can contact the training department, and that's fine if you're an SCW employee or one of our customers. Send an email to training@scweurodrive.com. Please do include MOVI-C class in the subject line so we can route it to the right person, and we will be glad to answer your questions. Just a reminder, however, the training department is not a technical support department. We cannot provide guidance on your specific applications. We can only answer questions about this course. If you do have a question about an application, please contact your local SCW Eurodrive representative for help. That might be, for example, your district sales manager, the local SCW office, or your local regional engineering support person. And they will certainly be glad to help you with technical questions or providing product assistance. So that is the end of session 19 and the end of the class. Gold star, good job. You did a wonderful job sticking with us, and I hope you learned something. I'm just going to mention this. We do plan to add a number of standalone MOVI-C control cabinet tutorials, which we will post on the YouTube channel. Do be on the lookout for those. They will cover other individual topics that didn't really merit inclusion in this class. And we hope that you continue to use MOVI-C control cabinet products in many exciting applications. Have a good day and see you in future trainings.